Since Earth is the only planet in our solar system where the concept of value actually means anything, perhaps you would argue that Earth is most valuable by default. Today we will discuss with you on the topic which planet is the most valuable one in the entire solar system. Welcome back. This is Ignatius Life. Earth's resources have been fueling humanity for thousands of years. After all, even if many of those resources are now running out, in fact, it's largely because we are running low on fuel that we are even sizing up the other planets at all, with cosmologically driven dollar signs in our eyes. Earthly fossil fuels like oil, coal, and natural gas are, of course, finite, which means we have to turn to either renewable sources of energy or to brand new fossil fuels reserves, both of which could be found on other worlds. Let's start closest to home. While clearly not a planet, the moon is rich in plenty of resources like silicon, iron, titanium, magnesium, and aluminum, as well as large quantities of water ice, all of which we could make good use. For many, though, the most vital lunar resource is the rare helium-3, which could potentially be used in nuclear fusion. Moon mining is all profits and happiness. As for actual planets, first out from the Sun is Mercury. It's one of the most mysterious of all solar system worlds, and if it wasn't for the messenger probe, we really wouldn't know much about it at all. We do know that its dark surface is because there is a large amount of carbon present, which we could use. We also know that there is a magnetic field here, an atmosphere, and temperate polarized caps, meaning that despite Mercury's close proximity to the Sun, it would be possible for humans to mine there. More specifically, we would probably mine for iron, which Mercury is thought to have huge amounts of. Asteroids also contains valuable iron ores, but Mercury would represent a much more stable and reliable mining field. Of course, the other big financial incentive with Mercury's solar power. With it so close to the Sun, we could cover Mercury in solar panels to collect energy, which we could then use to power spacecraft leaving the planet and traveling back to Earth. Next is Venus, where there are plenty of well-known obstacles. Chief among them is the surface in general, which is incredibly hot at around 880 degrees Fahrenheit and loaded with carbon dioxide and sulfuric acid. This isn't just bad news for humans, but also for any robots and machinery we might use to collect resources remotely. Most of everything gets fried, which means building any kind of mining rig would be incredibly difficult from the outset. As for the resources that are actually available, however, it might well be worth working out the considerable complexities to get there. Because Venus is so similar to Earth in size and structure, we think it probably has similar resources to us too. And it might also be a source of hydrogen too, a dense hydrogen isotope which could double up as fuel. Regardless, it's Mars that we appear most likely to actually first visit. So what will we find on the red planet when we get there? Well, Mars has volcanic activity, and as a result, plenty of ore deposit for all kinds of valuable elements including titanium, calcium, and aluminum, plus another high volume of iron to give this planet its distinct color. Mars' low gravity and an incredibly thin atmosphere arguably make it a difficult home for humanity. But we have already had robots roaming its landscapes for years. In the future, we may well see decades of remote resource gathering using AL just to prepare Mars for human settlers, meaning that it would take a long time to repay any kind of return on a big investment. But no other planet in the solar system right now carries quite as much prestige as Mars seemingly does, and you just can't put a price tag on converting the second planet for the human race. With Jupiter, though the first of the gas giants and the largest planet of all, there are even more possibilities. If we developed a way to extract resources from any of the outer four gaseous planets, then we would have a seemingly endless supply of hydrogen. And the atmosphere on Jupiter itself is 90% hydrogen, something which we use today in the manufacture of everything from food to electronics. Jupiter's probably rocky core is potentially made out of valuable ice and minerals too. But the problem is getting there. As you travel further and further toward it, the weight of all that gas would crush you long before you even saw that core, let alone set up a mining post on it. What makes Jupiter most interesting then are its many moons. Ganymede is actually the largest moon in the entire solar system, but it's Io and Europa which tend to draw more attention. Io is very volcanically active, which makes it equal parts intriguing and dangerous. Meanwhile, it's long been suspected that Europa holds a rich subsurface ocean, which could even host alien life of its own, a truly priceless discovery if it were ever made. Moving out, and Saturn's outer atmosphere is made up of 96% hydrogen, again making it valuable as a potential fuel source. Saturn is also famed for its rings, and while all four gas giants do have ring systems, Saturn's are the biggest and brightest. They are made almost entirely out of ice as well, so again they double as a water source. Perhaps the most exciting thing about Saturn, however, in relation to resources and potential value, is Titan. Like Jupiter's Europa, Titan, the Saturn's largest moon, has subsurface oceans that researchers think could be hosting alien life. But Titan also has its own atmosphere and boasts the most hydrocarbons of anywhere in the solar system, with hydrocarbons being the organic compounds at the heart of most combustible fuels, and with Titan having hundreds of times more hydrocarbons than ever Earth does. It's no wonder that some of our most ambitious space exploration schemes have Titan in their sights. Finally, the ice giants Uranus and Neptune, which, as their name suggests, are both primarily made up of different ices, water ice, ammonia ice, and methane ice. Both then offer potentially boundless fuel supplies, and both also have loads of moons to explore. But the excitement around Uranus and Neptune hasn't yet grown to match anything surrounding the other solar system locations, especially Titan. Perhaps the biggest pull from a financial standpoint to visit these two would be to investigate Neptune's strange color. Both it and Uranus are blue, but Neptune is such a vivid and distinct shade of blue that some scientists think that there might be a secret element hiding there to cause this mysterious hue. For now, though, who knows what it is, if it exists, or if it could be monetized. Clearly, traveling the solar system so thoroughly is still the stuff of dreams only, and if we ever could make the trip, then it would surely cost an inordinate amount of money. But theoretically speaking, pricing up the planets is something which can be done. For renewables, it's hard to pass up Mercury as the pinnacle of solar power. Elsewhere there's Mars, which is resource-rich and demands a far shorter commute. But perhaps the most valuable parts of the solar system aren't actually planets at all. It's the moons that are getting people most excited now. Most notably, Europa and Titan.